Right. Hello everyone, this is Prahash Palanki and this is my video presentation of my findings on the upper management questions of the final project, the course CPSC 6180 Software Estimation and Measurement. So as you can see here, these were the questions on your left hand side, and I was given that I am the project manager for an online ordering system where the customers can use various payment methods to purchase their gift cards. So as you can see, the gift cards database has the system management module and purchase, browse and return gift cards, and the customer module also has the purchase, browse and return gift cards and credit card payment module. And there is an external module called as payment and billing system. So it has two modules. For one is for system management and other is for customers and database and the other components. So I have already written my answers in the report and submitted it to the professor. So it is in the right hand side, the PDF answers. So this is the questions. What is the risk quadrant? What risk quadrant would the external payment and billing system be in, and why? So as per my findings, the external payment and billing system is as you can see in this figure on the left hand side, it is linked with the credit card payment module, which comes under the customer module. So it is independently verifiable as it is an external module getting added to the system. The level of integration is minimal and the usage is standard for the supplier. So the level of customization is very low. So it comes under the low risk quadrant, as the professor explained in his video lectures, that if an external module is getting added to the system, then its level of integration and customization is low, and hence it comes under the low risk quadrant. And the second question is also similar. He asked that if you added another external module for handling marketing operations, what risk quadrant would it be in and why? So it's the same as more and more we add external modules to the system, the integration and customization level is very low. So it is independently verifiable with the standard usage for the supplier. So if we add another external module after these two, then it also comes in the low risk quadrant. And the third question was, what is the estimate of the total number of defects in the system? And it told me to use these equations: ft equal to k 1 minus e power minus t square by 2t square by m, and ft equal to kt e minus t square by 2t square m by t square m, instead of the equations 7.4.1.1. So as you can see, I have it is told in the question that to assume that we are concluding the development phase of the project and we are now currently in the system test. So I observed that in this figure, defect counts, the x-axis is the months, and the y-axis is the defects found. So the maximum defects found in this case is in the third month, which is 25 defects, and so the total estimate of defects in the system should be calculated by, like, in the first month it has got around 13 defects, in the second month it has got 23 defects, so 13 23 is around 36, and in the third month is 25. So 36 and 25 is 61, and in the fourth month it has got 22. In the fifth month it has got around 17 or 18. In the sixth month it has got 5. So if we add all of them, it would be more than 104 defects found. So it's around 5 plus 17 is 22. 22 plus 22 is 44. 44 and 25, 69. 69 plus 22, 81. 81 and 13 is 104. So it's around 104 defects found. That's the total number of defects in the system. The fourth question: what is your recommendation of when to deploy the product and why? So often the problems show up at the deployment of the product, which are actually the failures of the requirement analysis, the requirement gathering phase. After that only the failures show up. So I would recommend that the product should be deployed after finding all the defects in the system, and it should fulfill all the requirements and should be designed and developed efficiently and finally tested properly, so that before getting into the hands of the customers. So after all this are successfully done, then you can release the software product to the real world. Fifth question was, what are appropriate failure severity classes for this system? The severity means that the degree of impact the defect has on the development of system. The failure severity classes are based on the impact of the cost, the impact of system capability, the impact of user, etc., depending on the system. So this system comes under the minor severity failure class, as cost and the system capability and the user impact is very low. So what is an appropriate failure intensity objective for the system? As per my findings, the appropriate failure intensity objective for this system is a severe defect per tester day as a project's goal for reliability. By tracking failure intensities during the testing, you should be able to determine you can raise or need to lower failure intensity objectives. So, and for the questions 7 to 11, the question is given that assume that we have shipped the product and it's been deployed for 2 months, and in that short time the server has been available 99.85% of the time. That is, the remaining 0.15% was due to the scheduled maintenance, and that the software modules were available 99.75% of the time. The remaining 0.25% was due to the bugs. The external payment and billing system had an available 99% with 1% due to unplanned outages, and only 50% of all transactions use the external payment and billing system, and the other 50% still work when the external system was unreachable. So the seventh question was, what is the availability of the system and was this acceptable? So the available time of the server was 99.85%, that is 0.9985, and the available time of software was 99.75%, that is 0.9975. So as we know the formula for calculating system availability, it can be calculated by multiplying software availability by into server availability. So hence the availability of the system is equal to software availability, that is 0.9985 into server availability, that is 0.9975. into 100 for converting it to percentage. So that is 0.996, and it's 99.6%. So yes, the 99.6% system availability is acceptable. And for the 8th question, I have been asked to analyze and predict the availability of the system for the following options. So 8th question was, if a secondary hardware system could be used during scheduled maintenance, reducing the scheduled maintenance time by 92.5%. So if it is reduced by 92.5%, that is 0.925, and the availability of the system would be 1 minus 0.925 into system availability, that is 0.075, that is into system availability, that is 0.996, as we have calculated in the above question, the question number 7. The system availability is 99.6. So 0.075 into 0.996, that comes up to 7.47% system availability if the scheduled maintenance time is reduced by 92.5%. The 9th question was, if a secondary provider with a predicted availability of 82.5% was used for external payment and billing system, if a primary provider was not immediately responding, use the secondary provider. So as given in the question, the external payment and billing system has availability of 99% with 1% due to unplanned outages, and so the availability of system is equal to 1 minus 0.99 into 365 into 24, that is 87.6 minutes per year, as equal to 87 hours and 36 minutes. And since the secondary provider used the system with the predicted availability of 82.5%, the system availability equal to 0.825 into 87.6%. Actually, the system availability here in the above should be 87.6% instead of hours and minutes per year, or hours and minutes. So that's my bad. So it should be 87.6%, and the system availability for the secondary provider used in the system will be 0.825 into 87.6, that will be 72.27%. And but only 50% of all transactions use the external payment and billing system, so therefore the system availability would be 0.5 into 72.27, that is 36.135%. So going forward to 10th question, the both secondary hardware system and secondary external payment and billing system. So the system availability has been got of a secondary hardware system in the question number 8 is 7.47%, and the secondary external payment and billing system is we got in the question number 9 is 36.135%. So for calculating the total system availability, we just multiply both the system availabilities of the secondary hardware system and secondary external payment and billing system, that is 7.47% multiplied by 36.135%, that comes up to 2.7% total system availability. And the last question for the upper management questions are, for each of these projects, what is the ROI, the return on investment for each year for the first 3 years, and what is the payback period? And so the client estimates a loss. Actually it's not an loss, it's an client estimates a loss of $15,000 per hour. The initial cost to implement the secondary hardware system was $55,000 for the first month, and for remaining 5 months from 2 to 6 it was $7,500. Then the contract to implement secondary payment and billing system $15,000 per month for 3 months, and after the development and testing, charges to maintain the system was $4,500 per month. So you can see, for calculating the return on investment, we have to calculate the net benefits and the investment we did for that. So we first calculate the net benefits. So the benefits for the first 3 years contract would be 15,000 multiplied by 3 times, that is for 3 months, and plus as 3 years is equal to 36 months, so 15,000 is for 3 months, and for remaining 33 months it will be multiplied by 4,500, that is for the charges to maintain the system after the development and testing. So it comes up to $193,500, the benefits for the first 3 years contract. And now the total cost would be the initial cost to make the software, that is $55,000, and the following remaining 5 months, that is 5 into 7,500. So it would be 55,000 plus 5 into 7,500, that comes up to $92,500, and the net benefits is equal to benefits minus cost, that is 193,500 minus 92,500, that comes up to $101,000. And the return on investment ROI is equal to net benefits upon investment. So $101,000 divided by $92,500 comes up to 1.091. So that is the return on investment, and the payback period is equal to, as this is the formula, initial investment upon annual operating cash flow amount. So the initial investment was $55,000 upon the annual operating cash flow amount is 33 into 4,500 into 12, so that it will be converted into months instead of years. So that comes up to 0.37 into 12, that's 4.44 months. That's a payback period for this project. So here are my references: the software estimation and measurement practical approach textbook, and here are some links I have used references from, and that's it. Those were my answers for the upper management's questions for the final project of this course. I hope you understood all the answers for this project, and thank you.